Okay, in last class we studied different types of groups from first year to zero group. We have written and we studied. Today I will explain. I want to write one more time group elements from first year to what seventh year and eighth group, zero group also. That is also called zero group. Okay, just you have to write once again for remembering purpose. You have to write once again. Okay, see first year group elements. First year group elements. What are first year group elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium, calcium. So first year group elements valence electronic configuration you know already. Valence electronic configuration is NS1, isn't it? Okay, you write down first year group elements. Hydrogen. Even though one more time you can write, then you get perfection. Okay, write down. So here valence electronic configuration, that is NS1. What are first year group elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Okay. In the same way, I write here second year. What are second year? Beryllium, magnesium, calcium, strontium, barium, radium. These are second year group elements. Their outer configuration is NS2. Then I write third year group elements. What are third year group elements? Boron, aluminium, gallium, indium, thallium. Boron, aluminium, gallium, indium, thallium. So outer configuration is NS2, NP1. See, look here. Boron, aluminium, gallium, indium, thallium. Outer configuration is NS2, NP1. That means these elements have 3 electrons, 3 valence electrons. 3 valence electrons means this belongs to third year group. Why these are placed on the third year group? Why these elements belongs to third year group means all are having 3 valence electrons. Valence electrons are 3. That's why group number is 3. This is very important you remember. Okay, don't forget this. Then I write fourth year group. What are fourth year group elements? Carbon, silicon, germanium, tin, lead. Carbon, silicon, germanium, tin, lead. So here the outer configuration is NS2, NP2. So valence electrons are 4. That's why these elements all are having 4 valence electrons. That's why their group number is 4. The same way, yesterday we wrote all this. Even though I can remind one more time. 58. What are 58 group elements? Nitrogen, phosphorus, arsenic, antimony, this one. Outer configuration should be NH2 NP3. Then 68 group elements. What are 68? Oxygen, sulfur, selenium, tellurium, polonium. Oxygen, sulfur, selenium, tellurium, polonium. Outer configuration is NH2 NP4. That means how many valence electrons are present in 68 group? 6 valence electrons. That's why group number is 6. So all are having 6 valence electrons. That's why it belongs to 68 group family. So their chemistry will be similar. All those elements are having same chemical properties because of same valence electronic configuration. This thing you will study in higher classes. Okay, it will be understanding in further classes. Okay. Then 7th year. What are 7th year? Fluorine, bromine, iodine, aspartate. Outer configuration is NS2 NP5. That means how many valence electrons? 7. That's why these elements are all are having 7 valence electrons. That's why belongs to these are belongs to 7th A group, and their chemistry is similar because all they have same valence electrons. Okay, this will be known in higher classes. Why these elements exhibit same properties? It will be understanding in higher classes. Then after this 8th A group, I already told you 8th A group is also called what? 0 group. This is also called 0 group. So what are 8th A group elements? Helium, neon, argon, krypton, xenon, radon. These are 8th or 0 group elements, and their configuration should be NH2 NP6. So 8 valence electrons are there. That's why these elements placed under 8th A group. Is it clear? Okay. Have you noted down? Have you written up to this? Okay, completed. The thing you try to listen, you hear. So here S1, S2 configuration means that means electrons are entering into s orbital. That's why these first A, second A elements are called what? S block. S block. I already told you, even though I explaining now, remember this. So from third A group to up to 0 or 8 group, here what happens? The coming electron, the last coming electron entering into p orbital, no? Entering into p1, p2, p3, p4, p5, p6. That's why from third A to 8A or 0, that is also called 0. These 6 group elements are called what? P block. P block. You remember this. The first two are S block, and the groups from third A to 8A, those are P block. Why these are called P block means here see electrons are gradually occupy the p orbital now from p1 to p6. That means electron enters into p orbital of what is that? P subcell. Nothing but valence subcell. That's why these are called P block. Is it clear? Okay. While studying periodic table, students will listen very carefully. While studying periodic table, you should have patience to understand, because this is a magical subject, and we have what is that? Somewhat you may face some task to understand. So you should note down. You should remember each and every point slowly, and copy down it in your running notes. Then you get perfection. So in between S block and B block, there is another block that is called what? D block elements. Okay, D block elements divided into 10 groups. 10 groups. Okay. Now I am going to explain the D block groups. Okay. How you did you write this? I want to remove. Okay. Then we will see D block groups. D block groups. See, write down from third group. Third, this is also called what? Third B. Third B. Group 2, eighth eighth A, B, C, and first B, comma second B. First B, comma second B. So the first B, second B groups also called. What are those groups are also called? 11th, comma 12th groups. 11th, comma 12th groups. 12th groups. So from third group to first B, second B, that means 11th, 12th, 11th, 12th groups total of 10 groups. 10 groups are present in between present in between S block, that means end group. Secondly, S block, in between S block to P block. Starting what is the third year? Starting third. You write of this. From third group to what is the 12th groups? Total of 10 groups are present in between S block and P block. Okay, are called B block groups. Are called B block groups. Which are shown below. You write down. You try to understand slowly because it's a complicated, complex topic. It takes some time to understand, but you don't bother. Go on practice. See, what is the third? Started from third B. This is also called third group. Then fourth B. This is fourth group. Fifth B. Fifth group. Sixth B. Sixth group. Seventh B. Seventh group. Then eighth group is divided into in different manner. What is that? Eighth group is divided into 8A. 8A group. 8A small a. 8 small b group. 8 small c group. This is called eighth group. Okay. Then after eighth, the remaining one is first B. So first B is also called ninth group. First B is a third, fourth, fifth, sixth, seventh. So here you try to listen. Seventh, this is eighth A. Okay, this is eighth B. This is eighth C. So this group eighth, this eighth A is eighth group. Eighth B is ninth group. Eighth C is 10th group. First B is 11th group. Okay, thereafter second group. This is 12th group. Okay, you try to observe, try to listen carefully. So third group is also called third B, fourth is also called fourth B, fifth B, sixth B, seventh B. But here there is a complex group. What is that? 8 is divided into two subgroups: A group, B group, C group. 8A is 8th group, 8 B is 9th group, 8 C is 10th group. First B is 11th group, second B is 12th group. After second B, what we come across 30th group, that is called what? 30th group is also called third A group. That is P block. Okay. You can, I think you can understand slowly. Don't bother. Try to. So in third B, the first element is scandium. Next titanium. This is beryllium. This is chromium. Okay, manganese. This is iron, cobalt, nickel, copper. See, red oils. Okay, these are the groups. Like that, we are having how many groups? Total of 10 groups. 10 groups. 10 groups. 10 groups. Okay, just you remember third B, that is first one and last one. Third group and 12th group. Second B, you remember for your understanding purpose. You remember this. And remaining are need not necessary here. That we will discuss in higher classes. So here scandium. After scandium here, yttrium. This is then lanthanum, then active. Okay. Okay. Here zinc, cadmium, mercury. Here no element, no element, because the last series is incomplete series. Okay. Actually, this is nothing but what fourth period. This is fourth period. This is fifth period. Fifth period. This is sixth period. Sixth period. Already you know, as you know, seventh period is incomplete. No? Seventh period is incomplete. Seventh period is incomplete. That's why here we don't know the element. Just to simply remember what is that first group and last group of the clear. Is it clear to you? Okay, have you completed this? Right up, right up. Take your time. So you have to remember, being a chemistry student, you have to remember at least this group, the first group of D block and the last group of D block. You have to remember these elements. What are these elements? See, this is scandium, you know, scandium. Then next, this is yttrium. This is called yttrium. This is lanthanum. Lanthanum, A lanthanum. This is AC, actinium, AC, actinium. In the same way, you have to remember Ag, last group. This is called what? Zinc, you know, zinc, cadmium. This is cadmium. This is mercury. So I think in atomic structure we have studied. No, this is cadmium atomic number is 21. You know, we are atomic number 22. This is atomic number 23, 24. You know, 25. 26 atomic number, 27, 28, 29, 30. Already we studied. I think you know this. Am I right? Okay. Then you know configuration also. Here 21 means configuration. Configuration. What is the configuration? Outer configuration. 3D1, 3D1, 4s2. You know 4s2, 3D1. Here in this last group having what 4s2, 3D10. 3D10. So from this, what we can understand here D1 no, here D10 no. That means electron enters into d orbital of penultimate cell. D orbital means here what happens? Electron continuously enters into D1, D2, D3, D4 like that D10. That's why all these are called what? Here the last coming electron, differentiating electron entering into d orbital of d subcell of and penultimate cell. That's why all these are called what? D block elements. Understood? Completed this? Have you completed this table? Okay, I want to remove. Let's see. See, the next following topic of your Olympiad syllabus, in Olympiad syllabus, the following topic is classification of elements, classification of elements into blocks, okay, into blocks, right on. Classification of elements into blocks. In periodic table, elements are classified into mainly four blocks based on their valency configuration, electronic configuration. So that means based on electronic configuration, mostly divided total elements in the table into four main blocks. What are those four main blocks? Means S block, P block, D block, A block. Okay. While running this class, we have reminded these blocks wherever necessary. I explained, but here we are going to discuss in detail. You write down this. So they are in the periodic table. Elements are classified into mainly four blocks based on their valency electronic configuration. So what are those? Number one, they are number one S block elements. Number two, P block elements. Number three, D block elements. Number four, F block elements. Write down. We will study one by one. So how many blocks are present in our log form of periodic table? Actually, it was proposed by paper scientists mostly. There are four blocks. So elements are classified into four blocks. What are those? The main blocks are S block, P block, D block, F block. Okay, come on, write down. We are going to discuss one by one in detail. Okay, completed, students. Then you write the heading. What is that S block elements? What is the definition of S block element? Now I am explaining S block element. What do you mean by S block elements? See, it's very simple. The elements in which the differentiating electron, nothing but the last coming electron, entering into, if it enters into s orbital, those are called S block elements. It's a very simple to understand. Just you write down. Just you can understand with notes only definition. So the elements, the elements in which differentiating electron. So differentiating means you don't bother. Differentiating electron, nothing but differentiating electron means last coming electron, differentiating electron. Actually, differentiating electron means the being is different. What is the differentiating? That means if electron continuously entering into group by group, so that what happens? Those properties are differentiating. That's why that is not differentiating electron, but simply remember last coming electron, differentiating electron enters into s orbital. S orbital of valence cell. S orbital of valence cell. Valence cell are called S block elements. Are called S block elements. Okay, this is the definition you remember. S block element means last coming electron or differentiating electron. If you enters into S orbital of valence cell, is called what? S block elements. Mainly first A group. You know, first A group is alkali, and second A group is alkaline, alkaline earth. Okay, first A group and second A group, alkali and alkaline earth metals. First A group and second A group metals are called S block elements. Are called S block elements. Why these are called S block elements? You know, first A group, valence electronic configuration. First A group valence electronic configuration is NS1. In the same way, second A group valence electronic configuration is NS2. Here you try to observe what happened. S1 means one electron enter into S orbital of valence subset. That means electron enter into S orbital. Here also electrons. NS2 means electron enter into S orbital. That means only the last coming electron or differentiating electron entering into S orbital of valence cell. This is called what? Valence cell. You know, this is valence electronic configuration. Valence electronic configuration. That means electron entering into S orbital of last subcell, valence cell. That's why these are called what? S block elements. Okay, is it clear? Okay. So these S block presents on left part of the periodic table. Left part of the periodic table. So while observing the long form of periodic table, the complete left portion is called what? S block. What are S block elements? First year, second. What is their configuration? NS1, NS2. Why these are called S block? With differentiating a last coming electron entering into S orbital of a valence cell. That's why these are called S block. That's it. This information is enough. Okay. Okay, students. Have you completed this? Okay. After completing S block elements, then next see P block elements. Second one P block elements. Write down P block elements. So what do you mean by P block elements? How can you define P block elements? The particular element is P block. That means here the elements in which differentiating electron or last coming electron enters into P orbital. Enters into P orbital of a valence cell. A very simple thing. Just I change here only orbital. Before S orbital is there. Just now I change in place of S I put here P. That means electron enters into P orbital of valence cell. Then these are called what? P block elements. Is it clear? P1. Write down. Okay. So what are P block elements? From third A group. Third A means 13th group. Third A means 13th group. Third A group. 8th A is also called what? 18th group. And also 0 group, you know, 18th group. From third A to 8th A, columns are called columns. Or groups. Columns are called P block elements. P block elements, P block elements. Their valency electronic configuration, their valency electronic configuration lies like this, lies from ns2 np1 ns2 np1 to ns2 np6. That means here what happened? The electron enters into continuously in p orbital of a valence shell. That's why these are called p block. Their valency electronic configuration range lies from ns2 np1 to ns2 np6. Okay, did you understand this? Do you understand what I am saying? Okay, this p block presents right side of the periodic table. Right side of the periodic table. Periodic table contains non-metals mostly. Contains non-metals mostly. Besides metals and metallites. Metals, comma metallites. Have you understood this? What I am writing here? So p block elements, most of the p block elements are non-metals, no doubt. But in addition to non-metals, there may be some are metals or metallites. Okay, do you understand this? Right. Okay, now I stop here. I conclude this session. The remaining part will continue in next class. Okay, I stop here. Bye.